We were discussing about the standard electrode potential, and we found the standard electrode potential can be of two types. Those elements who tend to lose electron, for them we say it is a oxidation potential, and those ions which like to gain electron, we call them as reduction potential. But we find that the oxidation and reduction is a simultaneous process. Only the case is that one is losing electron, other is gaining it, and amount of energy requirement is less. Same only. So the magnitude of this oxidation potential and reduction potential are same. Just to differentiate, we put a negative sign. So for for that, we found that whatever the value of reduction potential will be there, if I put a negative sign, that will indicate the oxidation potential, and for if I put a positive sign, that will be the oxidation potential. Okay, now we have to calculate those values. Experimentally, you have to determine these values. Now the question is very interesting. See here, if you want to measure anything, the value will be more or value will be less. If the value is more, we put it in the positive side, and if the value is less, we put it in the negative side. But the unit of measurement is same only. Say, take the example of the height of a mountain and height of a river or sea. In both the cases, we are using meter scale. Say we say that the highest mountain is Mount Everest, sorry, Himalaya, and the highest peak in this world is Mount Everest. But that is not perfectly correct. You may feel that I am giving you, because these are the days of all of fake news. So I am giving you fake news, then it will be, whatever I am saying is not fake, is correct only. Because Mount Everest is the highest peak if you think if it is above the sea level. But there are some submerged mountains are there in the Pacific area, where some submerged mountains are there whose height is more than that of Mount Everest. And we find there are some areas are there in Pacific Ocean. If you can take out the entire Mount Everest area, and if you drop them there, you will find it will sink. All right. But anyway, the depth of Mount Everest, the height of Mount Everest is 28,000 some feet. And but when you measure some deep part of the ocean, we use the same scale. Then how do you express it? In that case, we express it either by putting a positive sign before Mount Everest or negative sign before the depth of the sea Pacific Ocean. Or we use an unit which you call it reference. Unit means reference. Reference is what? We call it sea level. So in that case, we write 28,000 some feet above sea level, and that will be below sea level. The measurement scale is same. So when you want to measure the electrode potential of the different electrodes, in that case also, we should be able to use the same scale, because you require a reference against whom you are going to complete. So now, which one to use it? So when I was discussing about the electrode potential, I have given you, in case of oxidation potential, I have written that H2 it is hydrogen is a unique element. Hydrogen can lose electron and hydrogen ion can gain electron. Okay, this is very, very rare, it hardly happens. So you will get here this. So this I can use it. This one I can use it to compare the oxidation potential of some elements. Why? Because oxidation is a process where the reagent helps them to lose electron and they themselves gain it. So they are going to gain it from hydrogen. Example, hydrogen combines with chlorine to give you HCl. So chlorine oxidizes hydrogen. Chlorine oxidizes hydrogen, that electron goes to chlorine. Similarly, hydrogen can gain electron. It is if some element of its own they give electron, then hydrogen can immediately take it from that. So we know any element which tends to give electron voluntarily, we call them as reducing agent. So we can find out from there. All right. So in electrochemical cell, we can use hydrogen as a reference cell. Okay. But one interesting thing is that hydrogen is a non-metal. So non-metal cannot conduct electricity. Then how we are going to use it? Anyway, we are going to do it. We'll use some technique because we know that I can use platinum as an electrode because platinum is an inert electrode. So here hydrogen is going to give electron to platinum, platinum will carry. Okay? Just like it is like that suppose you ordered some food from outside. From the hotel, the cook makes it and you eat it. Who carries it? The person who, the courier carries it from that place. So courier has nothing to do with the food. Courier does not know how to make food also. His only duty is to bring it from the source up to the destination. So we are going to construct a hydrogen electrode. We are going to construct a standard hydrogen electrode. Okay, in short form we call SH. See, in standard hydrogen electrode, what you do? You take a glass tube. Okay, you take a glass tube and we seal one platinum layer. And at the end, we'll have a platinum plate. Okay, and so this is a platinum wire, and this is a platinum foil, and it's being coated with platinum black powder. It's called platinum black. And this will be dipped in 1 molar solution of an acid. 1 molar solution. Generally, we take here HCl solution, 1 molar. All right. And one glass will be there. That look. Through that we pass Pure and dry hydrogen gas under 1 bar. So this acts as a hydrogen electrode. Okay. Now, before I write something that day, I forgot to tell you one thing. How do you express an electrochemical cell? I am very, very sorry. See, every time it is not possible for us to draw the electrochemical cell. So remember that galvanic cell that you have written here. Galvanic cell where you take zinc in zinc electrolyte and copper in copper electrolyte as being connected internally by what? We connect it internally by a salt bridge. So in that case, how do the way we draw the cell, exactly we are going to write it in this. All right. So we can write now zinc. This left hand side we have put zinc anode. Then what we have there now? Zinc sulfate aqueous solution. And here I have put what the concentration of this one? 1 molar. Now you have salt bridge. Salt bridge. So we'll put 2 bars. Then after the salt bridge is being dipped in zinc sulfate solution and is being dipped in copper sulfate. So it is copper sulfate. I need not write here aqueous because it is already known here. So 1 molar. Then what do you have here now? Copper. So this is the cell represented. Cell represented. Cell representation. Or what you can write? You can write like zinc 2 plus. Write it like and copper. I'm very sorry. This is cell representation. So any cell you can write it for that one. Okay. Now, how to represent electrode potential? See, electrode potential. Okay, I'll write it later. Electrode potential, I'll write. So this is the standard hydrogen electrode. Moment you say standard, see, we put the value. What is called 1 molar. And what is this? It is hydrogen. So now, here, what we and this standard hydrogen electrode, that potential, we are only going to fix it. So what is the value now? We are electrode potential of hydrogen, standard electrode potential of hydrogen. We write like this: E0 H plus H2. We consider it to be 0.004 that we have assumed. This is the place. So this is the value. Now, how do you represent standard hydrogen electrode here? See here. You have used platinum. So representation of SH. How will you write? Instead of drawing, how we are going to write it? So we'll write like this. Platinum. Then we'll write now here H plus 1 molar. Then we'll write here H2 G 1. So this is the representation of standard hydrogen electrode. And what is the electrode potential of standard hydrogen electrode? Is 0.00 volt. Please draw. Okay. Can I rub it? Hello. Description you can read from book, I told you. One thing which is not being given in the CBSE book is the limitation of standard hydrogen electrode. That I am going to write. Generally in practical, our normal laboratory we do not use standard hydrogen electrode because it has some limitations.
Done, sir.
Okay. This you should know. Limitations of standard hydrogen electrode. 1. It is difficult to maintain concentration of dilute acid. For example, 1 molar HCl for long time because experiment takes time. Second, it is difficult to maintain 1 bar pressure of hydrogen gas for long time. Third, platinum electrodes. Electrode under electrode easily get poison in presence of impurity. These are the 3 difficulty. So these I have written only for your entrance exam. This is not being given in your book. Okay. What should be the replacement of this one? So, right here. In order to avoid such difficulties. Standard hydrogen electrodes are replaced by calomel electrode. Then what is calomel? Calomel is G2Cl2. Please remember, it's called mercurous chloride. Mercurous chloride is called calomel. The oxidation state of mercury is 1. And mercury chloride, HgCl2, is known as corrosive sublimate. It is highly poisonous. Okay. So, calomel electrode is what? Calomel electrode. Is being nothing but Hg2Cl2 in presence of mercury. There are two types of calomel electrodes out there. One we call it saturated, other is just forget about this value. It is not required. Only remember that it is calomel electrode. Here standard hydrogen electrode. Here the value is not 0.00 volt. It is 0.0028. Forget. That is I am not going to write. Knowing too much is also not good. Okay. So now determination. Wait. Before that, I like to tell you. I have not told you something very serious. It is called, because I have not taken any book. It is called EMF or Electromotive Force. Whenever a force is there, movement is there. Whenever a movement is there, there should be some gradient. See, an object which is lying in the plane, it will not move. If you want to move it, either you put tilt in this side or you put tilt in this side. Then only is going to move. Okay? What is electromotive force? It is the difference of standard electrode potentials of two electrodes in an electrochemical cell. Correct? N is expressed as E0. Okay, now how to write E0 cell? See, E0 cell is E0 reduction plus E0 oxidation. So now we know oxidation is what? Inversely proportional to it is inverse of reduction. So I cannot put any plus, I have to put minus. So reduction takes place where? Reduction takes place at the cathode. So we'll write now here E0 cathode minus E0 anode. To make it more specific, suppose you forget, we always put cathode on the right. So you can write here E0 right minus E0 left. So this is the EMF, or equal to
Done, sir.
right now, yeah. Determination of standard reduction standard electrode potential of anode. I write here. For example, zinc, because we have done zinc in the galvanic cell. So what I'll do now, see. So zinc is anode. Is applicable for any anode. Please excuse me for my bad drawing. Okay, you could understand what is this. This is zinc and this is SH. This is cathode and this is What you have here? Copper sulfate.
আমি যে পাশের বাড়ি বৌদি ছোট ভাইয়ের বউয়া পদ্ধতি বল না
one more. Okay. And now I'll connect it to the galvanometer. Okay, this. So we switch it on. We find the galvanometer reads 0.76 volt. What is this? This is the EM. Okay, now I'll write here. E0 cell is equal to E0 cathode and E0 anode. This EMF is how much? 0.76 volt. What is cathode here? Is standard hydrogen electrode. So E0 H plus H2. What is this here? What is anode? Zn2 plus Z. So now we know what is the value of this? 0.00 volt. This is E0 Zn2 plus Z. So therefore, this is the way we find out what any anode. And this is, for example, because you have taken galvanic cell. In the normal galvanic cell, we put zinc. So I have got it for zinc. Right. This one you know 0.00 volt. All the values you will get it.
Yes, sir.
Okay. Now we'll do what? Cathode. In galvanic cell we have used copper as
এমনিতে ধরো গেলাম ঠিক আছে একটু গিয়ে বসে গল্প করে এবার তো ভিডিওর মধ্যে দিয়ে যাবই আমি তো যাবই না আমার অত ইয়ে নেই মনে মনেই
I will not draw anything. You can draw. Okay. Here I will put copper, and here this will be this. So it will be HCl, and this will be copper sulfate. 1 molar. And value will be EMF. Please draw. We'll draw it again.
So why is it on the right hand side there's SHE again?
Which one? Here?
Right hand side.
Oh, no. This is isotope. So here I will write. Here cathode is copper. And this is hydrogen electrode.
একটু প্রজাপতির গায়ে দিয়ে সামনে বলে দিতে।
See here. So this way, we could find out the standard electrode potential of all metals and non-metals. And their value will be different. So we can find out, generally these days, you can arrange them in order of the reduction potential, or you can use in the oxidation potential. But now, according to IUPAC, these are being arranged in order of the standard reduction potential. Okay. So you get a series, and that series is called electrochemical series. Electrochemical series. When the electrodes in contact with their ions, are arranged on the basis of their standard. You write standard both reduction or oxidation potential, huh? But now I say we strictly follow reduction potential. Standard reduction potential. The series is called electrochemical series. Of electrochemical series. It is if you take any element, generally metal only, which is a negative standard reduction potential, and if you join it with standard hydrogen electrode, then it is going to act as an anode. Okay. On the other hand, those with positive value will act as anode. With reference to what? With reference to the substances having negative standard reduction potential are placed below hydrogen. Why? Because E0 H plus H2 equal to 0.00 volt. In the electrochemical series. And those with positive values are placed above. I'm following your book. You know, your book is negative is given below and positive is given up. But in some book, you'll find positive they put up and negative they put, positive they put down and negative put up. But your book, whatever that book is being written, is exactly because of the under the SI system. So it is correct. Why? Negative should be always below and positive should be always up. Okay. So now we'll go for third. The metals with lower standard reduction potential have the tendency to lose electrons. That is, undergo oxidation or are reducing agent. See, they lose electron means they give it to others. While the metals with higher value, higher and lower is what? With reference to this, not in the table. Metals with higher values have, sorry, I will not write metals, well, the elements with higher values have the tendency to gain electrons. That is, undergo reduction or what? Oxidizing so don't get confused. They gain the electron. How they will gain? They will take electron from others. So they are acting as the oxidizing agents.
That's
See, now I'll give you two examples. I'm going to write two electrochemical cells now. What? The cell is below second one is
hello. আমার মনে হচ্ছে এটাই কথা আমিও রান্না করে আছি আমি খবরের খবরটার জন্য ফোন করেছিলাম তারপরে মিতুকে বললাম
okay. See here, very interesting. This is as you write the cell, draw the cell. Here is anode. This is cathode. Same thing is acting as anode here and acting as a cathode here. See. Here Zn2 plus Zn is minus 0.76 volt and E0 Cu2 plus Cu is plus. I don't put plus here. Here E0 Cu2 plus Cu is 0.34 volt and E0 Ag plus Ag is 0.80 volt. See, this is lower acting as a cathode. And so here this one is losing electron, it is a reducing agent. This is higher, it is gaining electron, because of that it is an oxidizing agent. See when here, in this case you will find A's value is lower and this value is higher. So it is acting as a cathode, sorry, anode, and this is acting as a cathode. So what we can say? We can say lower the value of standard electrode potential. I will not write lower value. Lower value of electron potential elements act as and higher value standard electrode potential. elements act as cathode. So we should not go for a myth that all metals act as an anode. No. Some metals act as an anode, and the same metal, when you put it along with others, it can act as cathode also. It's just like that. If you compare your wealth with a person who is very rich in Shillong, I do not know who is the person who is very rich in Shillong, assume it is X. Then in that case, you are poor, he is very rich. But if you compare his wealth with any corporate sector, say in Assam, then he may be poor and a fellow from Assam will be rich. If you compare then with the national level, then that fellow from Assam will be poor and other one will be rich. If you go to the international level, it will be like this. All right. So it is not destined that someone should always act as a node and someone should always act as cathode.
That's sir.
Now applications of electrochemicals. Applications of electrochemical series. See here. First, reactivity of elements. Something you know, that is elements with, you can choose also now, oxidation reducing agent. Elements with lower value of reduction potential. It may be negative or less positive. They are going to act as a reducing agent. And elements with higher value of reduction potential, it may be less negative or more positive. They are going to act as an oxidizing agents. Okay. So now you already know the elements with lower with higher no, I'll not write like elements with negative reduction potential will act. You have to change it. Element with higher negative electrode potential or less positive electrode potential in comparison with others will act as a matter reducing agent and vice versa. That is, if you take the opposite way, more positive, less negative, they will act as a stronger, so act as a oxidizing. So from there you can choose it. So now within that also we can compare. Higher the negative value, stronger is the reducing agent, and higher the positive value, stronger is the agent. Earlier people used to do heat and trial method. Now you know the theory. If you want to start a reaction, simply look at the chart. Suppose you want to go for a reduction reaction and you want to use a metal. You don't go for this thing, experiment. Simply look at the chart. Take the metal and carry out. Suppose you find if the metal is strong reducing agent and may create problem in your reaction, then you take a milder reducing agent. The strongest reducing agent is lithium. Okay. So if you go for lithium, it may create problem. Don't go for lithium, you go for a milder one. If you find that your molecule can be easily reduced, then why should you go? Suppose you require a tablet, then do you ask your doctor to put you on drip? Obviously not. Second. So now I can give you an example. What is the example? See, zinc is having minus 0.76 volt. Copper is having 0.34. Now see, you know it. E0, water in galvanic cell, these people have done. They did not have any idea of this. And E0, copper 2 plus copper, you know it is 0.34 volt. So this is going to give electron and is going to take it. Because of that, see here in this beaker, you found that blue color has started fading and copper started depositing. This is the example. Now, see a very interesting thing. Electrode potential of chlorine. Okay. Chlorine is more positive than bromine. See here. So it will act as an oxidizing agent. All right. So let me remove this. I'll write it like Br minus. So chlorine is going to take electron from bromine. Oxidizing agent always take electron from the others. So what is going to happen? See, very interesting. You will find bromine liquid will be separated. See, the solution will be colorless. When you pass chlorine, the solution will turn brown. Why? Because the chlorine has oxidized bromide to bromine. This is more positive and this is less positive. Okay? If you wish, I can give you the value, but I have to search for it. So it helps us to displace elements from their
Done, sir.
okay. So now, second, calculation of EMF of a electrochemical cell. Earlier you used to put all voltmeter, voltmeter, everything circuit you have to put. Now you don't have to put. How can you do? See, you'll get the value from the table, and you know now E0 cathode minus E0 anode. So you get it from there. You can find out the E0 of a cell. Okay. Third, feasibility of an electrochemical cell. Suppose you constructed a cell, you can find out whether the cathode and anode you have put is correct or not. It may happen that suppose thing which you are supposed to put as anode, you put as cathode, and cathode has become anode. So in that case, cell, the reaction will not occur. How do you know? Because we know it is a spontaneous redox reaction, redox process. So in that case, what we can do? I can calculate this. If this value is negative, then you are going to find this is going to act, and that we have in class 11 also we have already discussed. NF 0 cell. See here. This is the value that you can get from here. If the E0 cell value is positive, then the value of delta G0 will be negative. Why you have to worry? See here, N is the number of electrons, F is the Faraday, so these are all, both of them are positive. So if this is also positive, then the whole thing will be negative. Say, by mistake you made a galvanic cell ulta. What did you do? You have written actual galvanic cell is this. This is the actual one. Okay. Actual. So what you have made? Because we write now from left to right. So in left side, instead of zinc, you have put copper. See see here. So what is the E0 cell here? E0 cell, you know cathode minus anode. So what is this value here? Here it is what? That you got from the book now? And what is this?
0.34.
Yes. So it is 0.34. All right. So it will be, sorry, minus 0.34 volt. So it comes to minus 1.1 volt. So if I put the value, what will get? What will be the value now? So it is, yes. So delta G, you know, the N is two moles of electrons, and this is 96,500 minus 1.1 volt. The value will be positive. The cell will not produce electricity. So much of help you get it from the electrochemical cell. So the cell is wrong. Cell construction is wrong. So you write will be right here. You write below the cell construction is wrong. So this is a wrong cell. So we can visibility of an electrochemical cell.
Sir, but when we connect it in the opposite way, won't the current flow in the opposite direction?
No. Yes, you are correct only, but authentically, in that case, always see if your current flows from the opposite direction, you are correct. But thing is that we made a mistake in the construction, is it not? So in that galvanic cell, zinc always has to be anode. If someone argues with you, no, copper is acting as a anode because I have put it on the left hand side, and zinc I put in the right hand side. So he will try to prove that as per the diagram, it is on the left, so it is anode, and it is on the right. You will say, yes, electricity is being produced, but in that case, the zinc is still acting as an anode, copper is acting as a cathode. That you can prove mathematically that your argument is wrong. Is it not?
Yes, sir.
Which metal will displace hydrogen from acids or water? Okay. Prediction of which metal shall displace, or means what? That is, you can prepare hydrogen. Shall displace hydrogen from acids or water. See here. Hydrogen has standard reduction potential of 0.00 volt. So only the metals having standard reduction potential less than 0.00 volt, or what? Or negative reduction potential. See, it is so logical. Potential can displace hydrogen from acids or water. You will find copper is 0.34. Because of that, copper cannot displace hydrogen. Silver cannot displace hydrogen. Gold cannot displace hydrogen. Mercury cannot displace hydrogen. Platinum cannot displace hydrogen. Therefore, metals like copper, silver, gold, mercury, platinum, etc. cannot displace hydrogen from acids or water.